Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is EL5, graphing a line parallel to an axis. We're going to start by taking a look at problem number 1. Draw the graph of each equation by using a table of values. State whether the graph creates a vertical or horizontal line. Well, the table of values is one way you can do this, but it's an option. You don't have to use the table of values. And the way I'm going to show you, actually, you won't need to use the table of values. So we'll start by taking a look at x equals minus 4. So I want to find, x equals positive 4. So I want to find positive 4 on my x-axis, which would be right here. And in order for that to remain a fixed value, the line has to run vertical to this. So I'm going to create a line that runs vertical through positive 4, and it only crosses x through that positive 4. It has numerous y values as you look up and down the line, but the x value does not change. And of course, we talked in class and stated that x is always going to give you a vertical line. Now let's take a look at x equals negative 3. Again, we should know we're going to have a vertical line. So we have negative 1, negative 2, negative 3. It's going to run right through here, looking similar to our red line, but in the negative side. And we name it x equals minus 3. And that's also going to be a vertical line. Now our y's, we should remember, run horizontally. So if I want y equals 4, I'm going to come over to y, the y-axis, look for positive 4, and I want to make a line that runs horizontally through positive 4. And I can then show that the y lines are always going to run horizontal. Same thing for my y equals 0. I'm going to find 0. I'm going to put a line that runs through 0. And that's also going to be a horizontal line. Now, if you had created a table for these, you might have different values for, let's say, in this case, y. For x equals negative 3, the y values would change as you move up and down. For x equals 4, the y values would change. For y equals 4, the x values could change as you move, but every x value is going to put you back on this line somewhere, because you're never going to get away from the fact that y equals 4. So, and you don't have to have a table to show that. All right, let's take a look at question number 2. Write the equation of a line parallel to the x-axis whose y-intercept is, in this case, a. The y-intercept is going to be 1. Well, just like we were talking about before, if the y-intercept is 1, that means that the only point in which this line is going to cross through y is at 1. The x values could change, but y is fixed. It's going to stay the same. So if we want a y-intercept of 1, we simply have to state y is equal to 1. And on the next one, they want a y-intercept of minus 5, which means we pull it down here. But again, the x values are going to change, but y is simply going to remain equal to minus 5. Take a look at number 3. Now we're doing an x-intercept, which means that the x is the fixed value and the y is the one that can change. So we need to show x as a 3. And if we take this and pull it over, we can put x on 3. And this line is going to run through 3. And the y values are going to change, but x has to remain equal to 3. Same thing if we go to negative 9 all the way down on this side. The fixed value of x is negative 9. The y values could be positive or negative depending upon whether you go up or down, below or above negative 9. But in order for that to remain constant, we have to say x equals negative 9. Number 5. They're asking you which statement is true about your graph of the equation x equals 5. Circle your answer. Well, I find it helpful to actually have a graph handy that you can take a look at. So let's show, here's where positive 5 would be, and if I had a line that ran through the point positive 5, it might look something like that. And now that I have this to look at, I can judge whether or not any of these things are accurate. So, is my line parallel to the y-axis? Well, yeah, because here's the y-axis and here's my line. They are parallel from one another. So that is true. And I can go ahead and circle that. Are any other pieces to this true? Number 2, it is parallel to the x-axis. Well, no, actually it's perpendicular to the x-axis because it runs right through it, so that's not true. It goes through the origin. Well, the origin is where x and y meet. That's a 0. It doesn't go anywhere near that, so that's not true. And it has a y-intercept. Does this line ever merge into y at any point, cross into it? No, it does not. So the only part that's true is number 1. It's parallel to the y-axis. Okay. Please use the questions that I've solved for you tonight to help answer the questions that you have remaining on your homework. And remember, the key to solving math is not only working hard, but working smart.